Hello, in this video I'll be talking about SnapView technology on VNX storage systems. This video has 4 sections. First, we'll go through an overview of SnapView and its 2 technologies, that is SnapView Snapshots and SnapView Clones. Then we'll do a feature comparison of snapshots and clones, which will provide a good understanding of which technology to use in which scenario. After that, a short demo in Unisphere to go over the configuration and management of SnapView. And finally, we'll look at where to find more detailed information about SnapView. SnapView is a block-based local data protection technology for VNX systems. It is a completely storage system-based product and so does not utilize any host CPU cycles. It provides up to 8 replicas per source. SnapView provides 2 different types of replicas for your production source. SnapView snapshots or snaps are logical point-in-time views of production data, whereas SnapView clones are full copy images of production data. SnapView allows multiple business processes to have concurrent parallel access to information by creating point-in-time views or multiple views of production data which can subsequently be made accessible to other hosts or simply held as a point-in-time copy for possible restoration. SnapView replicas are both readable as well as writable. Now let's do a feature comparison between snapshots and clones. This will help us understand which technology to use based on the business requirements. Space required. The essential difference between clone and snapshots is that clones are fully populated binary copies of the source and so will require 100% of the source space per clone, whereas snapshots are pointer-based copies of the source, which will only keep track of changed data on the source and so will require approximately 10 to 20% space of the source per snapshot. Performance impact. Due to clone being a full copy of source, once it is fractured, it will service parallel I/O without incurring any performance impact on the source. However, a snapshot will have some performance impact due to spindle contention when reads by secondary host or copy on first write operations are directed on the source LUN. Independent device. Clone is an independent device once it is fractured, whereas snapshot is not an independent device because it requires the source LUN for its operation. Hardware failure of source LUN. In such a case, clone will be fully functional assuming it is created on different drives from source LUN. However, since snapshot is dependent on source LUN, it won't be accessible. Readable and writable. Both snapshots and clones are readable as well as writable. Instant restore. Both provides the capability of instant restore in case either point-in-time copy is required. Let's go through a demo on how to configure and manage SnapView in Unisphere. This is the landing page in Unisphere when you first log in. We'll select the VNX system that we want to manage. This is the system dashboard. We'll customize the view blocks to provide information on data protection. These view blocks provide at a glance view of replication summary on this VNX system. As we can see that 2 LUNs are being used for local replication and that we have 1 snapshot session and 1 clone source on this VNX system. Now we'll go through the configuration for snapshots and clones. All replication options can be found under the Data Protection tab in Unisphere. We will use the LUN snapshot wizard to configure SnapView snapshots. This wizard will guide us through a step-by-step process of configuring snapshots. First, we select the production server to which the source LUN is connected. Then, select the VNX system which has the source LUN. Add the source LUN that needs to be replicated. For the purpose of this demo, we'll keep the default storage overhead values for snapshot. We'll also keep the option to create a snapshot at this time. And finally, we'll assign it to a secondary server. This wizard selects a source LUN connected to a production server, creates a snapshot, and assigns it to a secondary server. We'll also create reserved LUNs which keep track of changed data. After that, we'll start a session. Once a session is started, it will keep track of the changed areas on the source LAN. Now, we'll activate the snapshot so that the secondary server can get access to a point-in-time view of when the session was started. At a later time, if there is a need to restore the point-in-time view, we can do that by performing a rollback operation. Now we'll go to the clone configuration wizard. This wizard will guide us through a step-by-step process of configuring clones. First, we select the production server to which the source LAN is connected. Then select the VNX system which has the source LAN. Add the source LAN that needs to be cloned. For the purpose of this demo, we'll keep the default clone name. Now we'll select a storage pool for the clone LAN. It is recommended that clone LAN should be on a different pool as the source LAN. And finally, assign the clone to a secondary server. This wizard selects a source LAN connected to a production server, creates a clone, and assigns it to a secondary server. Once the clone is created, it will automatically perform a full synchronization, which will copy all the contents from the source LAN so that the clone is a completely redundant copy of the source. The process of synchronization will take some time depending on the size of the clone LAN. Once the clone is completely synchronized, we can fracture the clone so that the secondary server can get access to a point-in-time view of the production LAN. At a later time, if there is a need to restore the point-in-time view, we can do that by performing a reverse synchronization operation. For more detailed information, take a look at the white papers for snapshots and clones on PowerLink.